This question is taken from CSEC past paper May-June 2014. It's our number 6 question, which usually focuses on integration. And as you can see, it accounts for 14 marks. That's 14 out of 100. So that's actually a significant number of marks. I think this question is a good one to do because it focuses on most aspects that you could be tested on under integration. Part A here, we have to evaluate. So this is a definite integral that we must evaluate. It's a polynomial. If you look at the function x by x squared minus 2, that's a polynomial when we expand the brackets. Part B is also a definite integral, but this time it's testing our knowledge of trigonometric functions, specifically cos x and the sin x functions. We need to know how to integrate those. Part C gives us a point through which a curve passes and also the gradient function of the curve, and we're required to determine the equation of the curve. This means that we have to integrate the gradient function in order to get y in terms of x. So we would actually have to separate the variables here, take the dx over onto the right hand side and integrate the left hand side with respect to y and the right hand side with respect to x. This is actually indefinite integration, so we would have a constant of integration here, which we could evaluate once we insert 2 in place of x and minus 5 in place of y. We could evaluate c and get the exact curve. Part 2 requires us to find an area of the finite region bounded by this curve, the x-axis, and 2 lines parallel to the y-axis, that is the line x equals 3 and x equals 4. So this again is definite integration between the limits of 4 and 3. Again, I want to reiterate the point that whenever we evaluate an integral, so we integrate between 2 specific limits, there is no need for a constant of integration to be introduced. The constant of integration is only introduced for indefinite integrals. That is useful to remember. So let us start with part A. So we're going to integrate x by x squared minus 2 between the limits of 4 and 2. So the first thing I would do is expand the bracket, so I would get x by x squared giving me x cubed minus 2x with respect to x. Now I'm going to actually carry out the integration process. So x to the 4th divided by 4 minus 2x would be 2x squared on 2, which would give me x squared. And I don't need a constant of integration because I'm integrating between the limits of 4 and 2. So let me now evaluate between 4 and 2. Anyway, I see an x, replace it with 4. Alright, and then I replace it with 2. So we get 2 to the 4th on 4 minus 2 squared, close round bracket, close square bracket. 4 to the power of 4, that is 256 on 4 minus 4 squared is 16 minus 2 to the power of 4, that's 16 on 4 minus 4. And 256 on 4 is 64 minus 16 minus, this will be 4 minus 4. and that will give me 48 minus 0, which is 48. So the integral of x by x squared minus 2 between the limits of 4 and 2 is equal to 48. Now I'm going to look at part B. I have another definite integral, this time of a trigonometric function 4 cos x plus 2 sin x. 4 cos x plus 2 sin x dx between the limits pi on 3 and 0. So my limits are given in terms of radians here, because we're dealing with trigonometric functions. So of course I would integrate term by term, and I would take any constants outside of the integral sign. Right, plus 2 times the integral between pi on 3 and 0 of sine x with respect to x. That's going to give me, alright, so the differential of cos x is minus sine x. The integral of cos x is sine x between pi on 3 and 0. And again, the differential of sine x is cos x. The integral of sine x is minus cos x between pi on 3 and 0. What I will do is take that minus sign outside. Minus 2. Take it outside of the square bracket. Okay, so my last line was 4 times sine x between pi on 3 and 0. So I'm going to evaluate that. That's going to be sine pi on 3 minus sine of 0 minus 2 times cos pi on 3 minus cos of 0. Sine of pi on 3, that is, pi on 3 is 60, sine of 60 is root 3 on 2. Sine of 0 is just 0, minus 2. Cos of pi on 3, that's cos of 60, which is a half, minus cos of 0 is 1. So that is 4 root 3 on 2, which is going to give me 2 root 3 minus 2 pi. A half minus 1 is minus a half. So that is 2 root 3 plus 1. Good. And that is the answer to part B. Evaluate the integral between pi on 3 and 0, leaving your answer in third form. So 2 root 3 plus 1 is the answer in third form. It's the most correct form of the answer. Part C. So a curve passes through the point 2 minus 5 and is such that its gradient function dy dx is equal to 6x squared minus 1. 6x squared minus 1. We separate the variables and integrate on the left with respect to y, on the right with respect to x. This is the integral of 1 with respect to y, so that's going to be y. And this is the integral of 6x squared minus 1 with respect to x. That is going to be 6x cubed on 3, which is 2x cubed. 2x cubed minus x plus a constant. This is an indefinite integral. Now, when we substitute our point P, the curve passes through P, which is 2 minus 5. 2 minus 5. Therefore, we substitute in y is minus 5, x is 2. We get minus 5 is equal to 2 times 2 cubed is 8, minus 2 plus c, minus 5 is 16 minus 2 plus c. Minus 5 minus 16 plus 2 is c. That is minus 21 plus 2, which is minus 19. c is minus 19. Therefore, y is 2x cubed minus x minus 19. That's the equation of the curve. And so this was C part 1. Now C part 2 requires us to find the area of the finite region bounded by the curve that we just found, the x-axis, and the lines x equals 3 and x equals 4. So that area, that's going to be a definite integral. So I'm just going to show you again. This is the curve. The area is equal to the integral between the limits 4 and 3, lines x equals 3 and x equals 4, of 2x cubed minus x minus 19 with respect to x. So we're going to have to evaluate that definite integral, and that will give us the area bounded by the curve, the x-axis, and the two lines, x equals 3 and x equals 4. Again, I'm going to integrate term by term. So the area is going to be equal to 2 times the integral between 4 and 3 of x cubed dx minus the integral between 4 and 3 of x dx minus the integral between 4 and 3 of 19 dx. That is 2 times, this will be x to the 4th on 4 minus, this will be x squared on 2 minus 19x. So that is going to be, I'm going to take the 4 out here, so this will be 2 over 4, which is a half, x to the 4 between 4 and 3. I'm going to take the half out here, x squared between 4 and 3, and I'm going to take the 19 out from here. That's going to give me a half by 4 to the 4 minus 3 to the 4 minus a half. 4 squared